Just one ping. If you're not able to give us a ping before after we've done the open ceremony, we'll move to the second presenter and wait for you, as in shoot.
It's a ping.
Oh, this is a ping. Wonderful. Pong.
This is a ping.
You want to do this for us? Or should I?
Oh, now.
Yeah.
Good afternoon. Thank you for being with us on the last session in Yokohama on sunny Friday. So I'm Alexei Melnikov, and
I'm Hank.
we're going to try to entertain you for the last session of the week. Okay. So if this is your first session and the first time with IETF, please read note well on relevant documents, but I hope you've been to IETF before another session, so you're aware of this already. So if you're participating in the room, please wear masks unless actively speaking at the microphone or presenting. I mean, you can use either on-site tool or the full tool. If you use the full one, please mute yourself. So no audio or video escapes into the room. Again, unless you're presenting. For remote participants, please don't share your audio and video unless you're asking questions or presenting as well.
And there's a mandatory requirement to either use the light or the on-site tool, because then you will be recorded in blue sheets. And that's important to assess what kind of room we will get. So attendance number is recorded by using the tools. Tools will also be used when we potentially do polls. So logging in is mandatory in many ways.
Yeah, okay, so this is a list of useful resources. If you are in the session, I assume you passed the test of being able to join Meet Echo. So we have a notes taker. Thank you, John. We have presentations. Let's get started. Very quickly, this is our agenda. And any agenda bashing? So we have technically we have only one document accepted into the working group, but I will announce then that the second one is also about to complete working group last call, and this will be official, and we'll start with Brendan. Brendan, do you want me to drive slides or do you want to control them?
I am happy to control them if you can pass over control.
Let me. Can you request control from your end, I think?
No, how about I just get you to control them then? That's fine.
Then you'll find it to the right that you can pass.
Oh, hold on. Yes.
Oh, there we go.
Okay.
Excellent. All right. So this is just a summary of the changes since the last time that you saw this deck or this document. I've added the NIST IoT device cybersecurity capability core baseline. The name of this draft, this is the second part. It's not really an update, but it's more of a comment. I've had a number of suggestions that we should have a better name for this draft. There's a couple of suggestions that have been passed around. I think that it would, either of them's fine with me. Maybe we need to look at that. But I think that maybe we shouldn't quite decide on that until we get to the last slide. So the NIST IoT device cybersecurity core capability core baseline has a fairly small number of requirements, but they're very broad. So most of them also have existing references to ENISA, which was fairly useful since I had already done the ENISA mapping. The NIST requirements do have a very different structure to the ENISA requirements, and this is sort of hinting towards what you're going to see on the last slide here. But in any case, the NIST common elements is essentially what I've used as the requirements. They've got a rationale column, but I've not put that in. The idea here is essentially that you're likely to use this mapping document in conjunction with one of the baseline requirements documents. So duplicating that kind of thing isn't really necessary. The idea here is that the common element is essentially the key that you use to join those tables. The IoT reference examples column, of course, is also not brought into that because it refers back to, ENISA and a bunch of other baseline requirements drafts. And so there's a question. If we keep things as they are, this is likely to keep expanding. I would say that we'd probably go for adding in ETSI at the cybersecurity for consumer IoT devices baseline requirements draft next, but there's a lot more. And that sort of leads into the question. So first off, I think we're going to need a lot more authors to handle the mappings of all these different requirements. But that being said, maybe that's not quite the right answer. Maybe we don't have quite the right structure here. I wonder if maybe what we should consider is producing a mapping draft for each one of the mappings that we want to do. And essentially what I have in mind here is that these drafts, if we were to do it that way, wouldn't have to be the living draft concept that we talked about previously, because each one of these requirements draft or documents that we bring in externally seems to be pretty long-lived. So in that sort of scenario, we'd need a mapping document for each one of those drafts. It means a lot more drafts that we'd be producing, but at the same time, each of them would give an implementer a guide to go from one set of requirements to the IETF and related technologies that they need to be able to implement that. I think that that's a way to keep the complexity manageable, because if we start trying to bring in all these different technologies, it's going to expand. It's going to end up pretty big. So I'm a little bit nervous to start in on, a thing that could easily end up being a 100-page draft as it grows over time, as opposed to several small drafts that do exactly what a particular implementer trying to match a specific set of baseline requirements needs. And so with that, I think that's the big question. I think that's the one thing that we need to answer before we can go forward. And I would like to get a idea of the feeling in the room on that.
So Michael, you first.
Hi, Michael Richardson. I guess I'll just start with the current document. I like what you've done with it. And I think that your goal, like in section, I don't know, 4.81, you have a requirement, and then you mentioned RFC 8520, right? And then 4.82, you have a requirement, and then you mentioned some TEEP architecture document. So I think that your goal is to say, and here's an IETF spec that works for that. And I think that's a really good way to go. That's really great. I agree with you that the next requirement to add is the ETSI. I think you mean the whatever 345 document there, the one with no default passwords and a bunch of other stuff in there. Is that the one you mean? Oh, maybe we lost him. Anyway, I'll assume it is. And I'll just say that that document doesn't have a lot of original content. It's mostly just saying what we already said again. So I think that in many cases, we will not
sorry,
add
I cut out there for a moment.
Yeah.
I got, the last thing I heard was, I think that's a really good way to go.
Okay, so my next point was about the ETSI cybersecurity document. I think that's the 345 document or something like that that talks about like no default passwords and updates and stuff like that. I don't remember the exact number. They're terrible numbers, but anyway, I have a lot of familiarity with that document except for its name, and I don't think it actually adds very much. There's not a lot of original content and like or innovative content, maybe. Right, without saying terrible things with the document.
Can anyone hear me?
Yeah, we can hear you, but you clearly can't hear us. It's weird. It's like, middle of the night there. It should be lots
Brendan,
of bandwidth in
you
UK.
are heard, but you might not hear us.
Shall I just continue, or for the rest of the room?
Yeah, please do.
Okay. So what I wanted to say is I don't think Etsy is going to add a lot of new things. It might add one or two new items.
We'll try refreshing.
Thanks. So IOTSF doesn't actually have any original content. It refers to everything else. You'll get no new items from that, and that's by design. I don't think you'll get a lot from IEC either. I can't speak for those other documents, the other three, NEMA, whatever. I don't think you'll get a lot more. So I don't think that this is not going to scale linearly. It's going to way sublinearly scale. So I would suggest that no, let's not break into many documents yet. Do it if we have to. And I will step up as a more author for your request if you need that there. So, but I just don't think I don't think this has to be a big long effort. I think we can pretty much wrap it up, except for places where we might argue about the right answer. And Brendan, I'll write that in an email since you missed half of it.
Or maybe we'll have it in the notes so he can rewatch this part of the YouTube. Yeah, I pretty much want to second what you said. It looks like there will be quite a lot of overlap. So creating just lots of little documents which have lots of same content is going to be, I think, probably more work than just keeping one document. And then from chair side, if there is a question about helping out with this, because this need more work, then we'll just find more editors. The other thing that a comment I would like to make is, I think because there is, this will evolve over time. I think most likely outcome is that we are going to have a document which will be snapshot and will periodically publish. I don't want to get into the debate about living documents and all of that, but if we probably at some point say, okay, this is good enough as of now. Let's publish RFC, and then we'll do BIS, and then et cetera, et cetera.
Brendan is back.
Eric?
So Eric, not Mike. Brendan, I see you're back. I don't know if you can hear us now.
I can hear you now. Thank you.
Okay. Yeah. There were some other comments that were presumably in the minute or in the recording, or whatever, but while you were gone. So I would actually not want to split this stuff up into multiple documents. And I mean, as an implementer, it's actually useful to be able to capture both sort of more consumer requirements as well as critical infrastructure ones, which I think this draft already does, right? And I think it's fine to freeze it because in many cases, I think we saw this stuff in the early days of IPv6, sort of different organizations, NIST, et cetera, coming with their set up profiles, requirements, whatever, right? That people tend to copy things, right? Whether it's across different countries or whatever. So it's not like they're going to come up with new things made out of whole cloth, and particularly when it comes to the technical requirements. We are likely to see more and more process requirements. Like, here's your secure software development practices you need to do to build a product to deliver into this market for this type of product, right? Those are already showing up. But I would argue that we shouldn't necessarily get too involved in that, because it's not like something that affects how protocols are actually specified. So I would actually keep it as one document, and at some point in time said, hey, this covers enough territory, we can actually go on and take the snapshot. Thank you.
All right, great. It sounds like the consensus. I don't know if we need any further, but it sounds like the consensus is to keep it all in one omnibus.
Yeah, and if you need help, we'll find you co-editors.
Yes, please.
Okay. Are we done with this? I think.
Brendan, were there more slides, or are you done?
Full deck.
Maybe he loses control when he drops.
Okay.
So this is a comparison of co-op security protocols. Was just adopted by IETF, and the 0.0 version has been uploaded. It's exactly the same as the last LVIG version. At least that was the intention. Next slide. So this draft has some history. It was originally discussed in core, then discussed in LVIG, and then adopted in LVIG, and now adopted in IETF. Much discussion in the middle, and then not so many revisions. Two reasons for that. One reason was that a lot of the specifications were not really stable. So we did a lot of work, and then we had to redo a lot of work. Also, I was on parental leave twice during these 3 years here. But now I think everything is looking much more stable, and I'm also not on parental leave. So I think hopefully we can ship this quite soon. High level, the document gives an overview of different security protocols. It just talks about message sizes. There is no privacy or security. What security should you have? There's nothing of that, even if I'm a security guy. This is just about message sizes. And I think the main content of the draft are the overview tables. There are 6 of them. Then the draft has a lot of lot of text describing why these numbers and what the assumptions are and how it's calculated and so on. Hopefully the numbers are correct. There was some the latest version has been some correction to DTLS and TLS that makes the DTLS and TLS numbers go up somewhat. This is the first. It shows DTLS and ad hoc with connection ID and these sets of algorithms, especially the asymmetric algorithms has a big difference on the message sizes, and then also what kind of options you use in the protocol. We ended up including quite many different options. I don't think there are so many mere variants that you can do in these protocols. Some of them might not make so much sense, but we try to include more and not. Next. Recent addition to the document is CTLS. And here is DTLS, TLS, and CTLS for a specific set of algorithms. This is without connection ID. CTLS here does support connection ID. Next slide. And then for DTLS, TLS, and CTLS, it makes quite a big difference what kind of algorithm you choose. If you choose P256 and ECDSA, the overhead is much higher than if you use X25519 and ED25519. While in ad hoc, there is no difference in message sizes. A bit unclear whether the difference will remain in CTLS or not, that we'll see. And these three tables show the handshake protocol, so the TLS, DTLS, handshake, and ad hoc. Next slide. Then the second half of the document talks about the record layer protocols in DTLS and TLS, as well as OSCORE and group OSCORE. And group OSCORE here for pairwise communication. So the document is limited to when you have two parties. There's no group communication in this document. That was a LVIG decision a while ago. And here this depends on the sequence number. In general, there's more details on the record layers and OSCORE, because here every byte matters a bit more than in the handshake, typically. The document also goes into GHC compression. That was added because that's targeted to compress DTLS. So that felt very relevant to add. Next slide. And here's a similar table, but here is the dependency on the connection sender ID instead. And next slide. And here's the third table. This is overhead without the tag or MAC at the end of the record layer. This makes sense for this. You can do for the record layer, cannot really do that for the handshake because it's a little bit more complex how it depends on that. Next slide. So current issues, one thing that needs to be done, and I will try to do that in the next few days or week, is to update the numbers based on the 08 CTLF draft. That changes quite a lot of the numbers and add also numbers for PSK. I asked for that. It's a little bit unclear, the numbers for CTLS right now. The draft changed to have EDDSA as an example, but the UTA draft for TLS IoT still mandates ECDSA and P256. I think the only thing this document needs to wait for is that CTLS is a bit more stable. Then I think we could ship this, and I think that could be this year. There's also minor points should verify the overhead with OSCOR ad hoc. This was just, might be 1 to 2 bytes wrong there. There were comments on in the adoption call about key ID in ad hoc. This is actually also true for CTLS. I don't think it adds so much to the document to add a different table to that. The differences are quite small. Bigger impact would be bigger of the assumptions. The bigger impact is splitting up DTLS in several records. Flight 2, I think actually many implementations do that, but that's not covered. And then fragmentation is a major overhead adder, but that's a bit more complex and more lower layer. Next version we will add SHIC. Was a point by Eric Klein. I don't know if it makes sense to, should probably have at least in text what the SHIC number would be for UDP co-op. I don't know if it makes sense to have any more numbers. If anybody has any suggestion for numbers or text or analysis that would be added, I'm happy to that. I think the main things is to IoT Ops decide what do we want, what should the content be in this document, and then we add that and then we ship it. Karsten.
Yeah, Karsten Bormann. I really like this as an implementer's menu because it shows what consequences certain choices have. So this is really a good thing to have around. Of course, at some point we want to freeze this and ship this as an RFC, but of course it's already very useful in its internet draft stage. I would prefer to have things that are unstable be clearly marked so in the tables. So the table shouldn't make a statement about CTLS because we don't know what that will be, but it should make a statement about CTLS-07 and
Yeah,
08 and
that's a good point.
all that stuff. With respect to SHIC, well, that goes in the same place GHC goes. Yeah, maybe you can compress some of the early messages as well. I haven't thought about that, but that is certainly something where we don't have established practice. So this would be a little bit, yeah, we would be guessing a bit how people will actually do this.
Yeah.
So yeah, maybe just mentioning it in the text and maybe pointing out on a single example what it actually saves you, what sort of the purpose here. Because essentially, whether to have SHIC or not to have SHIC is pretty much an orthogonal discussion to everything else. Of course, at some point we would like to know how well the various protocols lend themselves to doing SHIC compression, but I think that's a separate draft.
Yeah, I agree.
Okay, Bill?
Hi, Bill Silverajan, Tampere University. So thank you for this draft. I think it's wonderful that it got adapted and it's been in development for so long. So that's good. That I had a couple of comments about the draft itself. So the point I would like to highlight is that the draft has a comparison of different CoAP security protocols, some of which are effectively transport layer protocols, and some which are the application layer protocols themselves, like ad hoc and OSCOR. So do you think that there is going to be a difficulty in mapping all kinds of transport layers that might add overheads to CoAP that are now being discussed, for example, CoAP over GAT and things like that? So
the document doesn't really talk about any of the, very little about the lower layers. There is like a sentence discussing that DTLS is over UDP, then you get this much extra, and TLS is over TCP, and then you get this much extra. My view of the document is that it should not be any more discussion of lower layers. This is about
Okay,
the
good.
security protocols themselves. I think
Okay.
that would be a
Yeah.
different
Okay,
document.
good.
Yeah.
So that same point led me to think about one other thing, which is that I'm sorry that I didn't do the actual calculation for the bytes, but it might be useful to have a table, include the table, a column about when CoAP is not used with any security protocols, what is the overhead as well. So the reason I'm saying this is also because if you're using TLS or any versions of TLS or any of the transport protocol that is based on TCP, there is also a TCP overhead as opposed to not using TCP and just plain UDP.
Yeah, I think if you take this document, this just the current numbers in the document is if you add DTLS or TLS or OSCOR or ad hoc on top of what you have, this is the number of extra bytes you get. So I'm not sure it fits, or how many bytes you have in the lower layers is might be a bit trickier and might depend on your network quite a lot.
Mm-hmm. But anyway, the TCP connection establishment is part of the security association also still.
Yeah. If you have any, there is a sentence about UDP and TCP. Feel free to suggest more text in that.
Sure. Yeah, I'll come to the mailing list. Yeah. Thank you.
Marco?
Marco Tiloka, thanks a lot. This is great work. Just a question on a table you showed before, I think was the one comparing sizes in the function of connection and sender ID. Can you show it again?
Yeah.
It was slide 6 or 7?
2 back maybe or something.
Yeah. It was a few slides back. Can you show that? A few slides
Sorry,
back.
did you want to
Go back 2 slides, I think.
Yes, the last row is probably better than that. Since the request is protected in pairwise mode, the response, regardless of the way you protect it, does not have to include the sender ID. So that's probably 11, 11, 11.
In group OSCOR, you said.
Yes. Yeah. I'll send the comment on the list too, but just wanted to double check with you. I guess there you're factoring the sender ID, but the response size too.
Yeah, I don't remember. Let's take that offline. I don't remember. It should be stated in the document how these were calculated. If it's not, it should be added, and then we should correct the numbers. There might still be. This was added like 2 versions ago. It might be. Let's correct that and check if it's correct. Yeah.
All right. Nobody else in the queue. Thank you. So next is ACME-based provisioning of IoT devices. Let me. Michael, would you like to drive your own slides by yourself, or do you want me to change them?
Why don't you go ahead and change it, because this will be my first time presenting via this Meet
Okay,
Echo.
sounds good.
So, yeah. All right. Well, welcome, Michael Sweet. I probably best known as creator of Cups and responsible for a whole lot of things with IPP, Internet Printing Protocol, AirPrint, and other printing related standards. And this is kind of where this started, is to somehow better deal with TLS certificates for printers, and it just happens to apply to a lot of IoT devices. So it's gotten a lot of review within the printer working group where we maintain IPP, and now here we are. Next slide, please. All right, so I've updated this draft 3 times, and basically it's intended to extend Acme so that you can do it locally and have a relatively safe way to discover this on your local network and manage it either in kind of an ad hoc way in a home network or in a very managed way in an enterprise network. And ultimately, the goal is we get rid of that scary browser security warning that says this website's going to steal your children and your money and everything else. And also just happen to get it so that you can actually securely access the embedded web server in your printer or refrigerator, or whatever it is that you're trying to access. Next slide. So on a typical home network, you have your Wi-Fi router modem. It's provided by the ISP, and it handles DHCP for handing out addresses and DNS pass-through, and does NAT and firewall and all that fun stuff. But it doesn't really do much traffic filtering. And if it has the functionality, it'll provide some sort of DMZ that you can say, pass this port number to this host on my local network. There may even be an embedded web interface for configuring or monitoring or speed testing or whatever. So when you connect to the network, you get your IP address and your default gateway and your DNS server and the domain name, which is usually the ISP's domain name, all via DHCP. And you know, if you have a printer or a camera or a refrigerator, you're probably going to be using some app on your phone to set it up, or the control panel on the printer, or name your Wi-Fi configuration standard, because that's what people expect. Next slide. Enterprise network is a bit different. Everything's managed. You can have multiple subnets, VLANs, and DHCP services are distributed throughout. Probably have a DNS service for the whole organization. Do all sorts of traffic filtering and load balancing and isolation, and it's a lot more locked down. And very likely you're probably using some sort of a directory service and authorization service, certificate server, etc. from your favorite vendor. And you put a device on the network, you need permission. And typically you have somebody in an IT department that's managing all these IoT devices. So naturally you end up with somebody that buys a printer for their cubicle and sticks it there and then gets a nasty visit from IT. Next slide, please. So Acme, probably aware of this, but just go through this. It's like Let's Encrypt was kind of the beginning of all this, and it allows everybody to have a trusted TLS certificate without having to pay for it. And it's great, but it doesn't work for the .local domain, and you can't do HTTP or DNS verification to local devices because you don't have access to the interior network. And dynamic DNS is still a work in progress. So if we put the Acme server locally, then obviously then it can access local devices and do all the things that we need it to do. But key issues there. How do we discover this Acme server? How do we trust the root certificate that server is using? And what are all the security considerations for this combination? Next slide, please. So for server discovery, and this is in the draft there, you first connect to the network. You're going to talk to the DHCP server, and there's a new DHCP option to specify an Acme server. And so if your router actually provides this, great, you've got the information you need, and then you can talk to the Acme server. If it doesn't, though, you probably have a DNS server and the local domain name, and you can talk to the DNS server to get the Acme server information that way. Once you have it, you can send the standard Acme certificate request. It does an HTTP verification and says, okay, yeah, you're actually there, and you're reporting the certificate that you're supposed to and all that information. And then from there, you get back the certificate you're supposed to use. And that basically is identical to the process for an internet visible host, just local. But MDNS can't be used for this because it's just not safe to do so, because anybody could just advertise that, hey, I'm an Acme server on the network, and cause all sorts of mayhem. Last thing here, normally you have one Acme server per network, but obviously you could do load balancing or DNS, and one host name becomes multiple addresses, and assuming you've written your software correctly, it all just works transparently. So that's kind of the idea behind the discovering the server. Next slide, please. So for the trust anchor, if you're in an enterprise, you're probably buying a certificate that you can use for creating your own within your enterprise, and so you can use that, and all of the standard X509 stuff that is present in these printers and in the clients can be used. But if not, then you have to create a self-signed certificate and then use that as your new root. So the idea here is a client or a printer or any other device that's on the network. Once you know what the local Acme server is, you can go connect to it, and as part of the TLS negotiation, you get back the certificate it's given itself, and that's where you get your root certificate from. The tricky part is, it's trust on first use, so there's always a chance for some sort of a man-in-the-middle attack. So you have to be very clear that it's only one that you will use while you're connected to that network, and it's only valid for .local and any site-specific domain that you may have gotten from DHCP. Next slide, please. So in the base Acme spec, they talk about things, certificates you shouldn't issue and so forth. So for the local Acme server, the restrictions are a little bit more specific. You're only allowed to issue certificates for .local and whatever site-specific domain is used on the network, so examplecorp.com. And naturally, you have to protect your root certificate and private key, support the revocation and reissue of certificates as needed, and you probably have a long duration self-signed root certificate or the CA signed root certificate, so that you don't have to worry about churn on the network. Every time you rekey, then the whole network has to recover from that. But at the same time, any certificates you issue, you do for a shorter duration, so that you minimize the exposure for any compromised systems. Next slide, please. So on the client device, the tricky part here is that local root certificate tied to a particular network, and if it's Ethernet, okay, well, it's whatever network you're connected to, and you can detect when you're disconnected and everything. For Wi-Fi, yay, we have multiple access points with the same SSID, and we may be roaming and all that fun stuff. So we have to decide how closely we want to tie the trust to the network here. the SSID isn't necessarily unique. You know, you could have a network name guest and multiple locations, and you don't necessarily want to treat them all the same guest. So you could use the MAC address of the access point, but then that isn't necessarily going to be authoritative. It's not authenticated anyway, and it can be spoofed. But you know, anybody can make a self-signed certificate as well, and so you know that the Acme server that you've talked to is got its private key, but it could also have compromised the real thing and cause problems. So all those wonderful security things that we have to deal with anyway come front center stage on this. So on the IoT devices, you have the usual things. You have to protect your certificates and private keys. You don't reuse them, and you need the ability to wipe the device because if you sell it, you don't want somebody else to inherit your stuff. And I want to say that's the last slide. Or no, we got one more. All right, one more, and then we'll start taking questions, I guess. So next slide. All right, so this last thing, and I kind of hinted at this at the beginning, if you're using self-signed root certificates, you're kind of trusting that who you talk to when you connect to the network is genuine. So, you have to kind of be comfortable with less than perfect security. And we talked a bit about whether or not browsers could somehow indicate when you're on an embedded web interface that this is not a CA signed certificate, but the research with handling EV certificates didn't turn up anything useful from that kind of user experience. And the other thing is could just be when you get that, instead of getting the this website's gonna steal your baby, that you actually say something like, this is a local device, and do you want to trust this? So in the end, if we have a centrally controlled root certificate, then we can actually better manage trust than we are currently with self-signed certificates. So that's all I have, aside from the draft there, which you're free to read. And I guess we can go on to some questions.
Okay, Brandon.
I really like this work, but I am very much concerned about the network identification part of it specifically.
For sure.
That is going to be a very big problem, and I think that we need a very concrete way to overcome it. I actually think that it might be simpler than it at first appears. I think that the identity of the Acme server is actually the network identity. I think that's all there is to it. If the identity of the Acme server changes, you're on a different network. And maybe that's the way to handle it. Network identity is Acme server identity, and there's nothing else to it. Beyond that, if you take any other tack, it looks to me like there are some pretty big security issues that need to be overcome. But if you take that specific tack, it should be fine. Yeah, happy to, if you've got ideas on other ways to get around that, but I think that's really...
that's actually the best idea I've heard so far, so.
Okay. Yeah, so I'm excited about where this is heading because I hate logging into my NAS at the moment. So yes, I want to see where this goes. Thank you.
Okay, Christian.
Thanks for this presentation. Christian Amsus here. I have two questions. The one is, do you have a roadmap how this could end up in actual browsers? Because without the certificate, without any local certificate that can installed in the browser, you replace don't click that message with install some certificate into your certificate storage, which is intentionally made more scary than, hey, this might steal your babies.
Yeah. Yeah. So, you know, catch-22, I have some interest expressed from the major OS vendors, but no concrete promises. And I think they're waiting for me to finish prototyping before they go any further. So yeah, that's kind of where it stands right now. There's interest, but kind of cautious, and I think part of it goes back to how do we deal with network identity, and I like the idea of Acme server identity fixes that, and then some practical issues on the back end. How do you flush out the trust root when you're not connected to that network?
I'll come back to the locality in the second question, but to me the important point here is you plan to go through the operating systems and hope that the browsers would actually use the certificate store that the operating system provides. Okay.
Yes.
So the second point for me is given that the topic of proving that we are currently in this local network and that we have the same idea of the right Acme server is rather hard. I'd like to raise the question whether it is actually useful. So when I'm talking to a printer, I'm connecting to it via some identifier. Is it so really useful to be sure that I'm talking to a printer that is part of my current local network or not? Because if it is not, then there might be a way easier route that we've also explored in some IETF work that is using the Acme infrastructure would be a great help here, to have vendor zones, basically vendor domains in which a device to which a device can connect, ideal in some cases online if internet connection is available to that device, and get some name like printer 1234567 dot printers dot some vendor.com, and that it could get signed with something that is already in the browser store, and that is completely accessible to the user. It also gives the green checkbox. It doesn't say it's local, but then again, that green checkbox, as you outlined earlier, will not make any different statement than we have a green checkbox. So why require that locality at all if it neither gives us added user experience that it contributes to the user visible security, and if it makes things more complicated than asking online?
So two issues, and we've had this discussion in the printer working group as well. How to be politically correct about this? The level of expertise and some of these security technologies isn't necessarily what we would want it to be for individual vendors to implement that kind of a solution where they are issuing certificates and also responding to DNS requests to provide a local address that will change over time. And not to mention there'd be privacy issues and all sorts of other wonderful gotchas there. And then on top of that, you have a lot of enterprises that want to have their printers to belong to their domain.
May I just
sure, go ahead.
The enterprises can still, and I think the IETF approach outlined that the enterprises can still use a local Acme service if they have all set up. But I'm thinking about the cases of I'm setting up something that I don't want to use expertise with, and then I get running without having an enterprise setup.
Yeah, I think my concern, and we've had these discussions in the printer working group as well, is it's a big ask to get printer manufacturers and you know, more widely any IoT device manufacturer to provide an Acme service or something like it, and a dynamic DNS service in order for the printer to be discoverable and usable. And then on top of that, generally speaking, unless you're in an enterprise, you're using multicast DNS and DNS service discovery to find and use a printer in the home. And the goal there is you have a .local name, and the only place you're going to get a resolution on that name is via MDNS. And the certificate, unless the vendor's certificate server will issue a certificate with, you know, the vendor domain and the local domain, you know, as subject alternate names, you know, the certificate you get wouldn't be usable on the network. So there's a lot of stuff that has to be done right with a vendor Acme server to get to the same sort of state. And you know, obviously you have to have an internet connection, and you have to be available to do that for the life of the printer, which could be 15 or 20 years. And it's also scalability. There's somewhere on the order of 1.5 to 2 billion network printers still in use.
Wes?
Thank you. All right. Wes Herdiger, ISI and ICANN board, but speaking with no hats. So I like the idea. I wish this problem was simpler to solve. I was in Best Buy the other day and I was trying to hit a button on a refrigerator and it kept popping up this error saying certificate invalid on the stupid little display panel, which is sort of akin and related. I think that there's a lot of security related things that are going to pop up that's going to make this harder and harder. And just the few that I were, thinking of, I understand the proposal, is even privilege differences between devices in a local network that may be trying to steal a certificate for another device or something like that, or rebrand under, a different name. What's preventing me from coming into a household or whatever, and then proclaiming that I'm something that I know I want to steal, a password from somebody else. And that may work okay in a home network because you're only going to trust your friends. I don't know how this will interestingly play with stuff on a public network in a coffee shop where I can spin up an Acme server and proclaim to be the Acme server for the network, and let alone fight with another Acme server. And so I think it's going to be really complex, and I encourage you to talk to the web browser vendors. They're very happy to talk to people generally. They won't like a lot of this, so they learned from the whole, EV cert. They learned from the whole, when you display a page with a button that says click through, if you really want to talk to your refrigerator, you'll click through and make bad decisions. We know that users don't like looking at URLs in anything and making security decisions on it. So, I wish this problem was easier to solve. Thanks, though.
Yeah, I do as well.
Right. Thank you. John?
Yeah, John Mattsson, Ericsson. This is something that should be solved, and it's probably hard. Just a comment, like these self-signed root certificates, the level of trust is necessarily reduced. Like basically all the root certificates are self-signed. I also don't understand what you mean with this. Like the current browser situation where you have like thousands and thousands of different CAs that can sign, that's not really the pinnacle of trust. It's what we have, but it's quite bad. Yeah, for example, we had like Trust Score a couple of months ago. What's realized they had like the post address in some 7-Eleven or something. Basically, the CA didn't really exist. It was owned by some nation state. And also, like if I have my network, I make a self-signed root CA, and that's the only thing that's trusted. That's a much higher level of trust than what you get in the browser. The difference is that you get a warning in the browser. That's a problem, but it's not really indication of how much the level of trust you have. Not at all. Yeah.
All right. Speaking as a co-chair, and we didn't have much time to discuss with Hank, but did you? Question number one: did you bring this to ACME working group?
I have posted to the ACME working group and asked for some feedback. I haven't gotten any yet, but I posted maybe a month ago, so I don't know if just people were getting ready for this meeting, or they have quite a few working drafts in the queue. So
okay, so I think either way, probably some collaboration will be needed, and
for sure.
Maybe it's a good idea next time for you to request some time at the ACME as well, just to make sure that they're aware of the work. And second, well, we'll try to, it looks like there is enough interest to do something about this work. I wouldn't quite say that we're ready to adopt this, but Michael Richardson was asking whether we should have a design team on this or not. We're not going to decide on the spot, but we'll have a think. Warren?
Thank you. Yeah, Warren Kumari, Google. So I think I will probably echo similar things to what Wes said. Like everyone, I would like this problem to go away, but I suspect that the security areas, people's heads will simply explode if you come along and sort of bring this to them. I'm pleasantly surprised that you say that some of the operating system vendors seemed somewhat interested, but have you spoken to the browser folk? Because I can't see them going for this at all. Like Chrome and Firefox, I could just see them sort of like saying, "Pooh, no," laughing and walking away.
So I had a very lukewarm reaction from one of the Safari people that responded to me on the Chrome side. I had a promise to look at it and haven't gotten a response back. And for Firefox, I haven't gotten any response. But my goal initially was just let's prove that this is possible and see if we can resolve some of the bigger security issues, because right now the position of, well, we're going to do nothing and we're just going to put up progressively scarier warning dialogues when you use the self-signed certificate, obviously can't be the solution. It's we're in a situation where we're asked to provide greater levels of security and trustworthiness, when we also have no way to provide that without requiring everybody to buy certificates, but we can't because the domain is .local, and no CA will issue a certificate for .local. So we have to do something, and it's just a matter of what.
Okay, thank you. Brandon?
Security folks' heads exploding, and I think that's probably accurate. So there's a question I want to pose And I think if we're not able to answer it, then I don't know what we can do with this. And the question is, if you had a device on your network that was intent on stealing your banking credentials, would you be able to stop it? Now, when I say intent, I mean it is pretending to be your bank. It is showing you your bank's page, your login page, and it's really just a pipe through. It's acting as a man in the middle. So, sorry, an on-path attacker. So you've got an on-path attacker on your network because one of your devices has been compromised. You go to log in, and don't think about you or me. Think about grandma. Grandma was trying to connect to the printer, but grandma is now looking at her bank login page. What happens next? If we don't have an answer for that, I don't think we can really do much. So I think that bears a lot of thinking about, because in this scenario, that attacker gets their little green check mark and everything's fine.
So I do think there's, if the local Acme server has issued a certificate for something called printer.local, and then another printer.local comes out and says, I want a certificate and here's my information, and it's different from the information it got the first time, then the Acme server is going to kick it back and say, you're not the printer.local I know. So I think we have some.
I totally appreciate that. I'm talking about the compromised printer, not a spurious printer, a compromised one.
Okay, so we compromise the credentials of the printer.
Not the credentials. It's
or
firmware.
the private key in the certificate there, and so we can impersonate the printer. And assuming
no, again, our attacker has code running on the printer to pretend to be other things.
Okay, so you just run your own code on the printer. Okay,
that's right.
So we do that, and quite frankly, whether you're using Acme with a local Acme server and self-signed certificate or a CA signed certificate, the problem is the same. You've compromised the printer, and now you're able to do things with it. That isn't a problem that this draft can solve or any draft can solve. It's a problem with the software and the protections on the printer.
Maybe this is a mud solution. Maybe this is a mud problem that I'm thinking of. Yeah. Okay.
Yeah.
Okay. Thank you.
All right. Thank you, Michael. This was a very interesting presentation and discussion. Thank you. Yeah, we'll come back to you about design team and all of this. But please maybe send an email to chairs to remind us that we promise you to have a bigger discussion and try to coordinate it, future work on this.
All right. Sure. Thank you.
Right. And the final presentation is update on the power of attorney-based device onboarding. Do you want me to drive it? Oh, okay, cool.
Hi, this is Sri presenting, and Ulo will be online. He's online. So we have, this is the 01 version, and we have presented the 00 version in 115. So as a summary, I can give a summary like the power. This is power of attorney based onboarding. So power of attorney based authorization, or POA based authorization, is an authorization technique where the user can grant their power or delegate their power to their trusted device, and so that the device can work on behalf of the user. So we were thinking how do we use this authorization technique to onboard IoT devices? In this proposed draft, we have different parties like principal and onboarding controller, the device, and the certificate authority. So the principal send a POA to the device so that the device can onboard to the local cloud via the onboarding controller. Yeah, so the main updates for this time is that, maybe next slide, please. Yeah, so there were discussions regarding the clarification of the features of the POA-based authorization in the draft. So we have clarified the offline feature of the POA, which means that the principal who generates the POA and send it to the IoT device and can go offline after the generation of POA. So this is an added feature that we missed last time. So we have clarified right now. And there was some discussions regarding the difference between FIDO onboarding and ownership voucher, stuff like that. So we have also added that part to the draft. And there were some discussions regarding ENIMA working group, how does it relates to the POA work. So yeah, I did read some drafts from that group, and I really need to learn more or dig deeper to understand what's exactly happening there. But I think there is a relation between POA-based authorization for onboarding and EAP onboarding discussed there. So I added an abstract of what's happening there to the draft. I also need to. It's really interesting. So I need to look into it more. And there were some comments regarding the JWT token format. So we were actually doing everything in JWT format, and there were discussions that you're using constrained devices. This is for IoT devices, so you need CBOR. Yes, we agreed to that, and we have considered CBOR, and it's also clarified in the draft. Next slide, please. Yeah, there were some comments regarding the revocation of the POA, which is we have some solutions. We don't know if that's the optimal one. So we can accomplish this by setting a low expiration time depending on your use case, so that the POA will not be for a long time the device cannot use that. So it you can reissue it periodically. That can be done, which is a solution how to revoke the POAs. Yeah, that is also added now to the draft. Next slide, please. I think it's the last. Okay, yeah, and we were talking about how to interpret the POA. How do the device or the onboarding controller can actually interpret, or how it can be decoded and validated at the other end when the principal generates and send it to the device. So this can be done similar to PGP. So you can download an image or a library in your local machine, or at your entity, this client or IoT device or the onboarding controller can download the library or image and can validate or interpret by themselves. So now it's available. A library that can be used for the interpretation is available right now. So yeah, you can check this link. So how to work. Mainly there are two functions: how to generate the POA and to validate the POA. We are also considering to add more. Next slide, please. Yeah, there were some discussions regarding the OAuth and the relationship between OAuth and POA. So we have written another draft on basically how can we combine, or how it's different or how it's similar. So yeah, this is available in this link, and we have also referred this new draft in the this 01 version. Next slide, please. I think it's the last one. Yeah. So the new version is available in this link, and reviews and comments are highly appreciated. And we are also looking for collaborators, co-authors to this draft for this draft. So if you have any questions, contact me or Ulo. Ulo, do you want to add something? We cannot hear you.
Sorry, now I got the microphone working. No, I think not much to add. Maybe we should mention that we have yet another draft where we are comparing the POA with all other proposals around.
based on questions that we may reinventing the wheel here and there. So we have yet another draft that we're not intending to go for a particular working group with, but we're covering basically all that we heard.
Yep.
Do you want to add on that draft 3? Do you want to add something on that?
Yeah, there is another draft for which explains how do we position the POA with the other existing works. So I haven't added that to the slides, but I can send it in the mail list. Any thoughts? Yep.
All right, thank you very much. There are no comments, other comments from the room, so thank you.
Yeah, thank you.
So, and at this point, we are at any other business. I'm sorry, we promised you will be free 15 minutes ago, but we took 15 minutes longer. So, do you really want any other business on Friday afternoon?
Yeah, it is.
Okay. Yeah, I asked for it, didn't I?
Yeah, customer, if you force us to generate any other business, I didn't have time for this IETF to generate some new material on 7 to 28 bits, which is another LWIG draft like the one we discussed, which may or may not be worked on by this working group. I still don't have a good answer whether it's in charter or not. But I expect to have something by San Francisco.
Okay. Yeah, I don't think we have a wildcard agreement that everything from LWIG can just migrate here. We need to ask every time for every document, but please do let us know.
Yeah, if I ask n area directors, I get n+1 answers.
Yeah.
So we need to consolidate these answers.
Okay, thank you. With that, any other business going once?
Going twice.
Going 3 times. Thank you, we're done. Yeah. I think this is probably the end of Yokohama IETF.
Yeah. Enjoy your stay, stay safe, and hope to see you all in the next 117 meeting. And yeah, and to see the movement in documents and some contributors. Bye-bye.
See you at the design team meeting. Bye.
Don't take your time. I don't run away.